Hey guys, welcome to 5.1 Notes, Example 1, Discrete Probability Distribution. So in this example, they like to call our mean the expected value. And you calculate it by finding each possible x value multiplied by the probability of each x value and the sum of that total. So remember, all of these probabilities should add to equal 1 if we can connect it to discrete probability. So also we could find the standard deviation, which is the spread of our data around the mean or expected value. Let's look at a real life example we can connect this to. At a carnival, you pay $2 to flip 3 coins. Each coin has one side with a 0 and the other side with 1. You win $1 for every one. Is it worth it? So before I can start this problem, let's see the possible outcomes. So I could get a 0, and then another 0, a 0, and then a 1, a 0, a 1, and a 0, then a 0, a 1, and a 1. Or I could get a 1, a 1, a 1, a 1, a 0, 1, a 1, a 1, a 0. And let me see, what am I missing? A 1, a 0, 0. And I believe that's all of the possibilities. So there's 8 total outcomes. So the possibilities for the number of ones is I could have 0 ones, I could have 1 1, I could have 2 ones, or I could have 3 ones. That's the ideal, right? If we get 3 ones, which is $3 back from the 2 that we pay. So the frequency, how many of my outcomes have 0 ones? Only this one. And the probability of that is 1 out of 8. Which is, let me just double check, 1 divided by 8 is 0.125. The next one is how many of my options have 1 1. There's 1, 2, 3 options. So the probability of that is 3 out of 8, which is 0.375. Now, how many of my outcomes have only 2 ones? 1, 2, 3. Another 3. 3 out of 8 is 0.375 probability. And then how many of them have all 3 ones? Only 1 possible option. 1 out of 8 is 0.125. Now, if I add all these probabilities up, they do sum to equal 1, which is why we can connect this to discrete random probability distribution. So x multiplied by the probability of x, I have 0 multiplied by 0.125 is 0. 1 multiplied by 0.375, 0.375. 2 multiplied by 0.375 is 0.75. And then 3 multiplied by its probability is 0.375. So now, in order to find my mean, which is my expected value, I need to add those up. 0 plus 0.375 plus 0.75 plus 0.375 is 150. So $1.50 is my expected value. But if I am going to spend $2 to play and my expected value back is $1.50 based on these probabilities, it's not worth it to me. So you see how we can connect probabilities to outcomes in determining what our expected value will be. Let's try another example.